Hello everyone. Today we're going to learn how to use the discriminant. Remember that the standard form of a quadratic equation is ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a does not equal 0. So these first three examples say state a, b, and c for the following quadratic equations. So remember that a is the coefficient in front of x squared, b is the coefficient in front of x, and c is the constant. So when I look at example 1, I can see that the coefficient in front of x squared is 4. So that's a. The coefficient in front of x is 3. So that's b. And my constant, c, is 2. On example 2, the coefficient of x squared is 1. Whenever you have an x or a variable and you don't see a coefficient in front of it, that means that the coefficient is 1. Because if it wasn't 1, then it wouldn't exist and it wouldn't be there. So my coefficient for a is 1. My coefficient for b is -3. And c, the constant, is 7. Go ahead and find a, b, and c for example 3. A is -3, b is -1, and c is 9. Now that we know how to identify a, b, and c, we can learn how to find the discriminant. The discriminant is a number, b squared minus 4ac. The reason why we find this number is because it can tell us a lot of different things about our quadratic equation. The first thing it can tell us is how many solutions we're going to have. It can also tell us the type of solution. So let me show you what I mean by that. It says quadratic equations with real number coefficients can have real or imaginary solutions. Yes, imaginary numbers are real. You will learn more about imaginary numbers in a different course. You can determine the type and number of solutions by using the discriminant. So let's look at this table. If the value of the discriminant is 0, then that means that you will get one real solution. When you have one real solution, that means that you have one x-intercept. If we look at the graph that they give us, this is my x-axis and this is my y-axis. I can see on this parabola, now remember, parabola is this U-shaped curve. That's the shape that quadratics make. On this parabola, I can see that it only touches the x-axis one time. So this is my one x-intercept, my one real solution. If the value of the discriminant is a positive number, so a number greater than 0, then that means that I will have two real solutions. Two real solutions means that I will have two x-intercepts. And I can see those two x-intercepts on this example, here and here. There's one other type of situation that we can have, and that is when our discriminant is a negative number, so a number less than 0. When this happens, that means that we will have no real solution. Instead, what will happen is that you will have two imaginary solutions. In this course, we're just going to say no real solutions. But when you get to another level of algebra, you'll learn about complex and imaginary numbers, and you'll learn how to find those types of solutions. So what does that mean in terms of our graph? That means that our graph will never cross the x-axis. And so there will be no x-intercepts. And we can see that on the graph that is given here. This graph will never cross this x-axis. And so that is why you have no real solutions. So let's try some examples. You can see at the top of this page that I've put the rules there to help you. And so just keep in mind that if your discriminant is 0, that means one real solution. If your discriminant is a positive number, that means 2 real solutions. And if your discriminant is a negative number, that means that it has no real solution. So it says, find the discriminant of the following quadratic equations, then state the number and types of solutions. So this is asking me to do 2 things. The first thing is to find the discriminant, and the second thing is to state the number and type of solutions. So 2 things for each problem. In order to be able to find the discriminant, I need to be able to state what A, B, and C are. So on number 1, A is 1, B is -6, and C is 10. And I'm going to go ahead and I am going to substitute into the discriminant, which again is B squared minus 4AC. Let me use a different color for that. Oops. And so when I do that, B is -6. So I'll have -6 squared minus 4 times A, which is 1, and C, which is 10. From here, you can either use the order of operations or you can use a calculator, still using the order of operations, however you want to do it. So I'm going to choose to use my brain. And so -6 squared is 36. -4 times 1 is -4. -4 times 10 is -40. 36 minus 40 is -4. So my discriminant is -4. When the discriminant is a negative number, that means that we have no real solution. So -4 is the discriminant, and that tells me that I have no solutions and that those solutions are real. So no real solutions. Let's try example 2. So first thing I need to do is determine A, B, and C. And my equation is x squared minus 6x plus 9 equals 0. So that means that A is 1, B is -6, and C is 9. And so I'm going to plug into our discriminant formula, which is B squared minus 4AC. When I do that, I'm going to get -6 squared minus 4 times 1 times 9. -6 squared is 36. -4 times 1 is -4 times 9 is -36. 36 minus 36 is 0. So my discriminant is 0. When the discriminant is 0, that means that we have one real solution. So if I were to solve this, I would get one answer, and that one answer would mean that I would have one x-intercept. What I would like you to do is go ahead and pause this video and see if you can find the discriminant for number 3. So on number 3, A is 1, B is -6, and C is 8. And so I'm going to plug into the discriminant formula, b squared minus 4ac. And when I do that, I'm going to get -6 squared minus 4 times 1 times 8. -6 squared is 36. -4 times 1 is -4, times 8 is -32. So my discriminant is 4. 4 is a positive number. When you get a positive number, that means that you're going to have 2 real solutions. And so what that means that if I were to solve this quadratic equation, I would get 2 real solutions as my answer, meaning that I would have 2 x-intercepts on my graph. Let's look at example 4. Remember that standard form is ax squared plus bx plus c equals 0. I know that I have my ax squared term because that's 5x squared. I know I have my constant because -1 doesn't have a variable. So I'm missing this bx term. Because that bx term is not there, that means that b is 0. Because 0 times x is 0, and so it would just go away. A is 5, and c is -1. So now that I know what A, B, and C are, I can go ahead and plug into the discriminant. And when I do that, I'm going to get 0 squared minus 4 times 5 times -1. Well, 0 squared is 0. -4 times 5 is -20. Times -1 is +20. 0 plus 20 is 20. My discriminant is 20. 20 is a positive number, so that means that I would have 2 real solutions.